Hello and welcome everybody to this new live streamed interview section, which is a segment of the already established Graph Stuff FM podcast, where we would dig down into different aspects of graph technologies and uncover their potential applications and talk about tech stack and value creation. My name is Max Anderson, and I'll be your host. And today we're going to be talking about something called digital twins. Innovation Vertex brings together different people from the industry that are leveraging graph technologies to further innovation and thought leaders in the landscape. And we bring these people together for some conversation and insights into into how you can leverage graph technologies to create value for your end customers and basically just explore the area and what you can do with it. And we'll try to take some questions as we go along from the audience and integrate that into the podcast. But for now, we'll also like to share what you're doing out there in the community. So if you have any cool projects that you're working on, please follow the link down here to let us know what you're working on, and perhaps you'll be a part of the stream in the future. All right. So today we have a guest, and that guest is no other than Philip Åsblom. Philip Åsblom is a co-founder and CTO of a company that works with digital twin solutions, and they are called Digital Tvilling. They're located in both Sweden and Norway, and they leverage graph technologies to drive innovation and create value for their customers. All right, welcome, Philip. See if you can hear. Can we hear you?
Yes, thank you very much.
All right. Well, your background is truly impressive, and it's clear that you have a passion for building businesses that helps us understand the world a lot better. So you co-founded this company in both Sweden and Norway, and you will get your chance to talk a little bit about the company and what you're doing and all of that stuff. But could you just tell me quickly how you got started?
Yeah, I think it's very hard to where to start the story. I think that for me personally, I've been interested in like complex systems for a very, very long time, way before I started working on how can you understand societies, how can you understand like political things, how can you understand technology? And for me, a lot of those things has been very much, I've not seen a strong division between what is technological system and what is organizational systems or political systems. For me, it's very much like intertwined. So that is probably where it all started many years ago.
All right. So you tend to look at things as a system of a system, and one system is helping another system grow, and is that how you look at it?
And exactly, and the opposite also, like that we have a lot of things that interact with each other, and to understand how different things are interacting and to try to capture what is happening in the real world is key for us before trying to understand how it happens or how can we affect what happens. So we come very much from what we sometimes call the kitchen sink realism. We look at the world as it is and try to understand what is going on, and then we try to find explanations for why different things is going on the way as it is.
That sounds amazing. So I know that you've already prepared a short pitch. So if you take that up, I'll put it on the stream, and you can tell us a little bit more about it, and we'll go from there as well.
Yeah, perfect. Yeah, so I will cover a little bit of the background of the observations that we have seen that we are trying to address at Digital Tvilling. So basically, what we are trying to do is that we try to bridge what we call organizational gaps. So if you look in the society, it's a lot of things that looks like this on a very schematic level. We have something at A that we want to move to B. And A can either be a person at a certain train station, and B can be the same person at another train station. It can be iron ore that needs to be transported or like coming out from the mountain, and B, we have actual steel. Or it could be like societal systems, young people going through an education system, ending up as engineers working for Neo4j. And what we tend to see in these kind of complex systems is that a lot of these, in many of these systems, it's so many different organizations here illustrated as the bubbles that needs to make their share, basically pull a little bit along this A to B journey in order to make this transition basically happening. And this can be transport systems where you have maybe someone making the timetable, another organization executing the timetable, another organization running the trains, another organization staffing the trains, so forth, so forth. And what all these organizations tend to have done during the years is to specialize and organize themselves into different kind of organizational subdivisions or organizational silos, if you are a little bit put a little bit of emotion into the word. And all of those sub-organizations has created their own governance structures, processes, service design teams, etc., to try to look at the world and steer their own thing. And it's quite hard to work across. What also has happened, a lot of digitalization has let's say cemented and put much more rigor into these organizational structures. So if you take the path dependence in this, and the rigidity becomes even stronger when you have IT systems backing up these different kind of processes that is part of the different streams. And this is like, it looks like a lot of bubbles, but usually it's way more bubbles if you look into real world systems. But we had like a core question: what happened with this A to B? And as it usually looks quite a lot like this, our observation in the world is that very often the real world, like moving A to B, the train from one station to another, or the iron ore from the mountain out to the harbor, or the school kid going in school, becoming an educated person at the other end, that reality is not captured in any kind of system because it's no one's responsibility to make those things happen. We have different fragments on it, and we have highly specialized people working in different parts of it, but the end-to-end chain doesn't really match up. So what we try to think about is, can we change this in any way? How can we focus on the reality instead of the different organizations' own needs? So we started 3 years ago. The background work is longer, but approximately 3 years ago we founded the company. And we then build digital twins that looks like reality visually, that captures the behavior of the reality. So if something moves in the real world, it should move in our system. and it's connected into reality in real time and captures history. So basically, we track a lot of real-time data, and then we get historical time series of that. And then we can use that to understand what is actually happening in the world and how can we forecast, to some kind of extent, the future. So it's very much like trying to see what is happening in the real world, trying to get the real world into the meeting rooms of these big organizations so that you can make decisions based on what happens out in the real world, instead of just looking at paper reports about what is an interpretation of what happened in the real world. Yeah, that's what we are trying to look at and understand.
All right, so let me kind of gather my thoughts, and so what I see here is some kind of, you're working with complexity and making kind of complexity observable from one perspective, right? So you can, if you have a very complex organization, or you have a very process, or basically anything that you can track, you can put in a system like this, right?
Yeah.
And could you, so are you more interested, like we've talked about systems before, are you more interested in kind of, trying to solve it from a systems perspective, or is it like the digital twin is the future, it's the technology to go, or
no, it's a good question. For me, it's like, we usually don't say that we solve so many things, because I think that the solution to one problem creates another problem at another end. So if you have this kind of system perspective, a lot of it is to try to make informed decisions on balance in different parts of the subsystems of the big system.
right.
So usually it's quite a lot of trying to show things how they are. What is the variation in different part of the system? How can we understand it? Can we get a joint view of how a system is performing, or what affects what? So that is usually where we go about. And then what we see, depending on the different domains you're in, it's very much, you need to have a lot of different specialists to try to understand what goes on in the system, because it's not a trivial thing to just observe it and say, is it good or bad, or how can we improve? What do we mean with improvement?
So basically, you would say that you could use a digital twin to basically get the oversight that you need to actually find where the issues are, and kind of identify them and make sure that they are not causing problems on the system as a whole, basically.
Yes, exactly. If you take a small ordinary factory or a print shop, you can walk into that building and observe what is happening. Like, okay, the paper is moving, we have people here, it seems like orders is coming in because we're shipping out things. You can get that overview and observability. But in complex systems and bigger systems, you can't step into a national transport system and get that feeling, because you need to be at all places at the same time. So I think that the system observability aspect of it is usually a common thing too, that it's the systems are so big that you usually can't stand in one place and look at them.
all right, so it's too much for one person to hold everything in their head, and
yeah, or just to see, because it's too long, standing in Kiruna trying to see Stockholm.
Yeah, I understand. So what would you say is like the target industries for digital twins? Like, is there some industries that are better suited for it, or is it something that applies to all?
Yeah, I think it depends a lot. I think that like digital twins, there's no like real consensus, I would say, on what people generally mean with digital twins. So if you take like digital twins of mechanical things, like a certain kind of machine or a car or something, that is what we usually call like the nuts and bolts level of a digital twin. I think that has a lot of applicability when it comes to industry and manufacturing, etc. What we tend to do is to take a little bit of the other approach, to try to capture things that are very disperse in their nature, not trying to model everything to the nut and bolt, but instead trying to cover the movements. And then I think that digital twins are very interesting for things that it's hard to look at in the ordinary world and get the grasp of what is going on. Then you can like add on data to try to get the observability and explainability. So I think that's things that at least for me, or it's maybe a personal preference for which kind of problems that you like to work with. For me personally, I like things that are real and that exists in the in the I would say the real world. I talk with
The
you.
real world. All right. So
Whatever we mean now with the real world. But I prefer things that are moving around in the real world that is not only financial transactions or economy, more
all right.
more things that you can touch usually.
So physical objects that you can track and has substance, right? Right.
Yes, and then of course there softer things is also important, like how does ideas spread, etc. That is also super interesting applicability for digital twins. But that is yeah, I would like to do more work in that, but we're not totally there yet.
All right. All right. So technology wise, someone that's interested in digital twins and want to know more about it, kind of, how do you get started? How do you kind of get into digital twins?
I think that people come from if you look at people that works with it today, people come from a set of different backgrounds. Some people are from the construction industry, some people come from engineering, some people come from like game development. So it's quite a mixed kind of backgrounds that people have. And I think that if you want to get into it, I think it's good to try to find, it's a big area, so it's good to try to find like one aspect that you're interested in. If you're very interested in data structures, then focus on the data structures. If you're very interested in visualization, focus on the visualization. But in
All right.
general, it is like there is something for everyone in the world of digital twins. If
Yeah.
you're interested in real things.
But generally it's all about like different types of connected data, so it's kind of, graph related in some way, and it's
Yeah,
a lot of data points that you have to kind of couple together and kind of get a greater understanding of how it connects, right?
yeah, especially for us it is that way, because we generally work with problems that is multi-organizational by the nature, and things that moves around between different organizations and different geographies. And then
Mhm.
graphs are very it's a very convenient way to describe the world, because the world is not always connected and the world is not standardized. The world is dispersed and it is full of different things, and then it is good, graph technologies are a good way to capture those kind of structures.
But you also have like related technologies, right? Like so digital twins does not really stand on their own legs. You have things like IoT, right? That you can have connected devices
Yeah,
that supply you with data, and you also have maybe some machine learning to do some predictive modeling and things like that. Do you see any other kind of technologies that might be kind of intertwined or connected?
yeah, so I think that first of all you need to like try to capture different kind of data, either create the data by sensors or find good other data sources that describes what you want to capture.
Hmm.
Then I think that you also have the as you say, like data structuring is a discipline in itself, and then you have analytics on top of this. How do you actually understand it? Machine learning, other kind of mechanisms, and then on top of it you have like the visualization layer. And I think a lot of focus in digital twins traditionally has been very much on the visual side, because it, of course, the visuals
All right.
are an important thing, but it's not the total thing. So I think that like if you're into the visualization side, there's a lot of aspects there for digital twins too, but only having things that looks like the world, like a game, doesn't capture the dynamic of the world, because it doesn't need to be connected. So if you take super good video games, they look like the real world very much,
Yeah.
but they don't really capture what is either what happens in the real world, or maybe they have super good models for emulating what happens in the virtual world, so to say. And
Yeah.
there you can take quite a lot of inspiration also, I think, to industry.
But like from a video games perspective, you probably too zoomed in to kind of grasp what's going on in a bigger scale. Is that what you're saying? Like you might
Uh,
need something that's more
I think that a lot of video game, or I every fifth year I think about, should I buy a video game or a video game or not, and I always ended up in no, because I think that I could not handle it. So I'm not an expert in games, but
yeah.
I think that you have games now, and have had games for a long time, that basically captures loads of very complex dynamics in a way that is far beyond the amount of dynamics that is captured in ordinary enterprise systems.
So let me ask you this. So when
mm.
you engage with a new customer and you start talking about what you can do for them, and so what is your kind of your value proposition? What is the driving force that they should choose you and work with digital twins, and you especially for digital twins?
Yeah, I think that we are usually, what to say, we don't have solutions to everyone. we are quite a lot of a niche player in some ways, because it's not that we need to sell to everyone either. We sell to the people that resonates with our way of thinking generally, which is quite a
All right.
nice thing to have it that way. And what usually resonates with those people that decides to work with us is that they have problems that is spanning multiple organizations, that they have a problem either understanding or solving. So in general, you need to find people that are interested in either that you have a business where you have a little bit of problems that you want to understand what goes on, or you have a business that works quite well that you want to transform into something else. So how can you then understand what goes on today to change it to something different?
All
But
right.
in general,
Yeah.
we sometimes joke in that we sell solutions to problems no one own. So we have long sales cycles because we need to have multiple people being
Because
part
you're
of
working with
being part of it.
complexity, right? And you want to kind of bring down those silos, and usually someone is usually in charge of a silo, and that is the problematic part of it.
Yeah, and it also, I think that it's also what keeps a lot of organizations going still. So it's
Right.
a very hard balance between it, because I think that you could benefit a lot from a systems perspective, but at the same time, you can't change. You need to do it in a way that is not changing the whole business, because the reason why a business exists is because it has a lot of path dependence that sometimes has worked very well and maybe might still is working very well, and other parts is not. And to differentiate what is what there is hard. So to capture what is happening in the business might be a good foundation for figuring out, okay, how should we actually change it? If you take like traditional consulting, you always talk about,
Right.
yeah, we have the as is analysis and to be, and then you do a gap analysis. And then you
Right.
always a
Right.
little bit sloppy with the as is, and then you define a to be thing in PowerPoint, but you never get there.
All right. Yeah.
Because you have all of these existing structures that is basically what makes the business run.
But could you put like what we talked about earlier to perspective? Some solution that you've built, that you've kind of engaged with digital twins, and what's kind of the outcomes of that, and how did you create value for that customer?
Yeah, so we can take one very specific example on the railway side, or railway or road side, depending on which silo you look at it from. So in Sweden, we have quite a big railway system because we are quite a big country with not so many people in it. And that railway system has been developed over 150 years approximately. And you still see a lot of traces in the railway system dating back to history that has a lot of explainability. Why is it as it is?
All right.
And if you take this very, very big infrastructure, Sweden has about 3,500 unattended railway crossings. And that is crossings between the railway, that has been traditionally the responsibility of one organization, and different roads that sometimes is owned by the state, sometimes by private people, and sometimes different municipalities. And every
So there's
year,
not like one person who owns everything. It's like it's a segmented kind of infrastructure.
Super segmented infrastructure. Some of it managed on the national level under legislation related to railway policy law, other parts relating to different things. So when you are on the railway, you have a mix of different, if you take the policy perspective, you need to follow the policy and the laws related to railway. On the side of it, you have other kind of laws, like how are you allowed to act when it comes to traffic safety when you're in the car versus walking. If it is a common road or a private road, it's different things.
Right.
And it's a very fragmented system. And it's like a very small example, but Sweden has like 3,500 unattended crossings. And every year, many accidents happens on those crossings. People die on the crossings, and people get injured on the crossings, both crossing by foot, by snowmobile, and cars and horses, etc. So you have a lot of different like things going on in this intersection of these two different means of transport, basically. And this is a problem that no one totally owns. So the Swedish government asked the Swedish Transport Agency to look into how can we create other kind of solutions to be able to warn for this. And there, as we had quite a good model for the railway system, including at least a partial coverage of high precision GPS positioning data. We were part of that tender, and then we did quite a lot of work related to how can we actually then use that information about where the train is.
So you kind of integrated an IoT project into a kind of digital twin solution, basically.
Yeah, exactly. So that we are able, or that we were able then to warn for trains at these unattended crossings, either to mobiles or inside car navigation systems. And this might sound like a trivial thing, but going back to my first sketch with like going from A to B in this model,
right?
The Swedish Transport Agency don't really know where the trains are. As it is an old system, you know usually which line segment the train is on, but those line segments can sometimes be kilometers, and you don't know how fast the train is moving. So you don't have a resolution talk like that about what is actually going on in the real world. You have a model that is, for historical reasons, very
so basically you don't know if someone is going to cross the section in a minute or 30 seconds or nothing like that. It's basically it could be an hour, it could be 5 minutes, it could be 2 seconds.
Yeah, exactly. And quite a lot of the Swedish railway, or not quite a lot, but parts of the Swedish railway don't even have an electricity grid next to the railway line.
Okay.
Because they're running on diesel locomotives.
All right.
And so there we basically had this case where we have this multiple different organizations. Sweden has 50 plus railway operators running on the Swedish railway network, where the Swedish Transport Agency, both their railroad side that is related to the railroad policy and the road side related to the road policy. And then we have been like looking into, and then we built the solution to be able to warn for trains at unattended crossings and to issue those kind of warnings into car navigation systems. And now we are like continuing that work to both start to roll it out a little bit to see how it works in the real world, because there's a lot of security considerations in those kind of solutions. But also like the railway is not there in isolation. How can we understand the transport on it? How can we understand, for example, when the railway don't run, how do people then move with the extra buses or
so you're trying to find extra data points. For example, can we call this company that has buses in the area if that train fails down and things like that? Then
yes, exactly.
All right. So is this integrated with some type of signaling between systems, or is more like an aggregate view of descriptive view of what's going on?
Both, I would say. So sometimes it's integrated into the system, actually feeding back into the system itself. When it comes to different systems, they are different levels of regulation and how you can actually use things. And if you take the railway system, it's slow to change in general. It's a lot of path dependence and history that makes it rigorous in change for good reasons, to say that, but still slow, and sometimes it's too slow.
All right, so let me ask you this. So if you wanted to dig down into the technical aspects of this, right? So how would you kind of set up your tech stack to accommodate what you're trying to solve, right? And why would you choose those technologies over other technologies?
Yeah. I can go into it like quite high level. I will not go into all the trade secrets of every corner of the solution. But I can walk through a couple of different patterns. So one is that we as you understand, we need to be able to integrate and lift in a wide variety of different data sources from a wide variety of different producing applications or sensors or things. And that is not easily solved. It's not that you just can set up and say to the client, please send us data on our this Kafka topic. You need to be able to handle a lot of different things. So if you take that, you have like the inbound integrations. You need to handle a variety of sources, and then of course you can standardize, etc. But it is quite a lot of work. And then like Node is a good way to build things there. And then when you get the data in, you need to process it so that you can handle the volumes and structure it up in a way that you then can use it for different kind of things. And sometimes you use it for analytics that is very down in the databases. And sometimes you need to lift out the data and using other kind of tools on like the statistical or machine learning side as well. So basically, we get the data, capture it, put it in databases, and then on top of that, we have quite a strong separation between our API layer that we're exposing those data sources on, and a set of different front-end applications that is using the data.
So are you using some kind of like 3-layer architecture, or are you using more like a microservices kind of approach where you would have different services handling different things, or?
It's like 3-layer mostly. And the reason for that is that, and the reason for that is that we are using, we are not on the cutting edge of all data processing and data science tools because we don't really need to. And a lot of our clients, they prefer like a nice REST service that is well documented, what to say, instead of something else. So we have quite a lot of like traditional things in that regard. And then what we've also seen is that when you're working with the visualization layers on top, sometimes you need to integrate, for example, if you have very high demands on visualization, that you want all the shadows and all the light, etc., to be very good, then you might want to use a game engine. But if you use a game engine, then that will not run super well on ordinary office workstations, as an example. Because you need to have quite a lot of hardware.
There's a little bit of a trade-off there, right?
Yeah, exactly. And there's loads of those kind of trade-offs, and therefore we have done this like layering that where we are separating out with our APIs quite clear from the different consuming applications on the front end, because then we can use a set of different front-end technologies and also evaluating different front-end technologies for how well they work for different kind of things. And we can also work with partnerships with other companies that are having a similar way of thinking in application development and utilize their tools when it comes to understanding complex systems. So we don't always need to do everything ourselves. We can find good partners around us.
All right, so you might have one partner that works on your visualization part, and you have another integration part to work on your data ingestion pipelines or whatever.
Exactly. And sometimes the clients have their standard that they want to visualize something specific in their like map solutions or their own like business intelligence solution or data science solution. Then we can provide the data, but we leave the we leave the visuals and some of the analytics to them. But it's very dependent on where the organizations are that we work with.
But usually I see challenges when you start to aggregate data from a lot of different data sources, you get like a data quality problem, because you might have duplicates, you might have things that are out of scope or things that are not relevant to the different kind of how do you kind of deal with that in a I mean it's a big question, but I mean, do you have a process that you work through to make sure that the data is up to date, or?
So in general there is no magic that solves this. it's work and thinking. In general, I can cover some things that we have learned doing this several times. One thing is to understand what is the data that we have or that we want to get in, and what is the requirements when it comes to data accuracy on it. Is it okay if it is a little bit sloppy? What do we mean with sloppy? What do we mean with off? What do we mean with old, new, etc.? So that you get the feeling for which level of data accuracy do you basically need.
All right.
And then we try also to get data that is based on the real world, not based on estimates. That's another thing. So in general, we ask when we look at data, what is this? Is this aggregates or is it real measurement points? So if you take temperature or speed, for example, that you want to understand, okay, do you guess what the speed is here? Is it or is it based on some kind of real number?
Is a derivative some way, like you might use this to estimate or do some type of analysis or
exactly. I would usually like to have not estimates, but having things that is measured out in the real world.
So basically, it's as simple as a simple type of measurement as you can get, basically.
Yeah, exactly, and to understand the precision of it. So that is like one part of it, and then you need to figure out what is the data that will live for a long time.
Yeah.
and what is the data that is okay to change, put in and throw out, etc., and experiment with. So you need to have a little bit of data governance processes in place to figure all of those things out.
Right.
And then with duplicates and data quality, etc., you need to, what is the consequence of it being wrong, and how wrong can you be, basically?
So, for example, if you have a train and it stops and suddenly a track is damaged or something like that, would you um, would that data get some kind of priority through your system then, or would it be um, what would be your solution to kind of feedback that information that might have to do some rescheduling or send buses or?
Yeah, it depends. Usually we don't have so much, like we are good at handling the data volumes that we have. So it's not that we need to cater for those kind of, we can manage the load we have,
Right.
if I say it that way. So we don't need to have the like different queues for the different speeds. We can process a lot of it quite fast. But it's like, yeah, in general, you want to separate so that you capture the data when you need to capture it, and
Right.
then you do the processing. And sometimes you need to do a little bit of processing up front to be able to capture it as well. But it's like, yeah, it's really one of these, it depends kind of questions. Data quality, yes, it is. It can be an issue, but usually I think that you usually solve it quite well. I think that a lot of focus traditionally has been so much on data standardization, which
Right.
to like our opinion is not super necessary, especially when you have good like graph technologies, then you can relate different things to each other, and the world is not standardized. Why should we believe that we can create standardized data structures when the world is not
It's
built
always
that way?
changing, right?
Yeah.
And but that is an interesting part of data, right? Like you look at it at one point in time, it might be described in one way, and then in a week or later, it might be described another way, and you're always trying to kind of force it back into its original form, but it's doesn't really work that way sometimes.
No.
But so on a personal level, how did you, like, when you thought about starting this company, how did you get into like digital twins? Had you been working with digital twins before, or was it something that just, you shined a light on and went for?
um, I've not really been working with digital twins in that sense before we started the company.
All right.
As I said, my background, I studied at university. I studied the master in socio-technical systems engineering. So
All
I
right.
studied like the history of ideas and mathematics in a weird combination. As I said, for me, I like to have a variety, look at a variety of different things. And then I started at IBM directly after I was finished studying, and I worked at IBM for close to 10 years. And then I worked quite a lot with system integration back in development, starting with that IT architecture, then moving into more advisory roles and program project management.
Right.
And then I felt that it was time for a change, and then I started to work within like a British management consulting firm doing advisory management consulting and being manager there for like 4 years. So and then got a little bit, I really felt that I needed to do something different. It became harder and harder to like mobilize the energy and feel that it was a fun thing to go to work.
Finding kind of a purpose in what you're doing, and yeah.
Exactly. And then I felt, and this was just as COVID started. And first I thought, okay, now you really need to hold on to the job now when the pandemic is here. And then it took a couple of months, and I realized, yes, you need to also take like you shouldn't put everything on hold and just hold on to everything. And
Right.
sometimes you need to just go a little bit with the luck and go a little bit with the feeling. So I basically decided that I could do whatever I wanted for a year at least, and then basically see what popped up and see where I ended up. And then I always liked working and I like to do things.
Right.
So I was not too worried about that. But then it was like trying to find a good context for things. And
All right.
then I run into this, and then I can have and then I realized, okay, so this is actually I've done quite a lot of system integration. That's a good thing to know.
Right.
I've been quite into statistics and probability analytics. That's quite a good thing, good thing to have.
Right.
So I basically started to see that, like, if I want to understand complex systems, why not build a system for understanding complex systems?
Had you worked
So it was
anything
a
with
lot of
graph
things.
databases and graph technologies before you started, or?
Not a little bit, but not really. I studied graph theory as in a mathematical sense at
Right.
university,
Right.
and I always found that mathematic to be the most beautiful one, actually. But then it was more like pen and paper and evidence based. So
All right.
I was I was very like into the field of graph theory, but
Right.
then I missed a little bit the wave of graph database, etc., when I was sitting with my PowerPoint and Excel files. So I've done a little bit of a comeback to technology.
Not really as intuitive, is it?
No, but I think that like when you start to yeah, so when I started to experiment a little bit with graph databases and what you can do with it these days, it was nice because it's like, yeah, it actually is a technology that is working well. In general,
Yeah.
especially compared to when you try to do this 15 years ago. It's a big
Right.
difference.
Right. Yeah, I can imagine. I mean, now me myself, I hadn't even heard about graph databases 15 years ago, and maybe I've heard about graph theory, but I mean, graphs were pretty new to me, and kind of opened up my eyes. So, what was your introduction to graph technologies? When did you first start using it?
I'm trying to think when I don't know. I think I downloaded Neo. If we take Neo4j specifically, I think I downloaded it like 3 years ago, maybe
All
5 years
right.
ago actually. Once I don't really remember because I think I downloaded it and never really got started first, and then I downloaded it again and tried to get started, but was like, okay, trying to look at Cipher and trying to figure out, oh, how can I get this syntax into my head?
Right.
Uh,
Right.
because I thought it looked a little bit awkward. And then I don't really remember, but then I had some kind of need and decided, okay, I will spend some time now sitting down with this and trying to do things. And then I think that the first thing I did was like creating some kind of, yeah, a set of different objects of different types and then relating the relationships to them.
Mhm.
And then I started to figure out, okay, so you can actually import data into this as well. And this might sound trivial, but but so you can actually take a file. Okay, well, which kind of files do I have that I can try to build graph structures of? So it was
Right. Right.
basically like that. It took a little bit of time to get into it.
So what was your, so you said 3 years ago is about the time you started your company as well. Was that
Yeah.
kind of your intention then to use this technology, or was it just trying to learn and understand how you could integrate that in infrastructures, or?
No, it was basically trying to start to read up a little bit and try out different
Mm,
kind of technologies. I like to be quite hands-on when it comes to
right.
technology development, to actually not only read them, but get a feeling for how it feels.
Right.
And then it was never an intention to use, okay, what can we use this technology for? That's not how it has been with graph databases. It's been much more, okay, this is a good tool in the toolbox
Right. Yeah.
to
So
solve the kind of problems that we are interested in solving or
right, right. So
understand the kind of
basically, it's the
problems.
other way around. You'll find some pain point, and you kind of identify, oh, yes, this might be a good technology to alleviate that pain point.
Yes, exactly. And
Right.
like it's very like handyman kind of thing. Okay, it works. Good. uh, uh, let's
Yeah.
go. Let's see where we can take it from here.
Wow. All right. Cool. So what? So now you've kind of kicked off this new venture, and you have new projects coming in. What is your kind of what's your vision for the future? Where are you trying to go? Are you building a product, or are you trying to just accumulate as much like services as possible, or
Mm.
what is the next step for you guys?
No, so basically, we are like a product company. We are a product company. So the way it
Hmm.
works is our client usually are subscription on our platform, and that platform consists of different components depending on what you subscribe on. So basically,
Right.
that has been quite a big of a drive from the beginning, that
Hmm.
we want to be a product customer. And then of course, these kind of solutions is a little bit more like a managed service kind of thing.
All
So it's
right.
not that we just click and get started yet. but you need to have a little bit of data. You need to have a little bit of an implementation of it to
Right.
get it up and running. And I think that is where we are going to continue to head. What we have seen is that the skill of understanding complex systems sometimes requires a little bit of hand-holding along the way.
Right.
So that is something that we have needed to be able to provide a little bit more of. What I see going forward is maybe maintaining like the base of the product, so to say, that is like the generalized system capturing the reality. That is the core. But then that you on top of that can have different industry solutions or very more niche kind of packagings on top of the general platform. And we are there, for example, with transport systems. There we have that. But in other systems, we need to get. I think that is probably where we're heading. Yeah, build
So you're
a little
trying
bit
to
more
kind of
custom things on top of it.
so basically you've been focusing on creating value. Now you're trying to streamline it, package it, and market it as a finished product that you can just like click and go with,
Yeah.
instead of having to kind of do all of that hand holding or do a lengthy onboarding process and stuff like that.
Yeah, a little bit, but I still think that you need to have a little bit of it will continue as the world is complex. The solutions representing the world will be complex, so it will still require a little bit of time and investment to be able to do that. But we have found during the years like good ways to accelerate that.
Right.
So I think that is one thing, and then I think that there is a lot of complex systems that we want to be better at understanding and do more work in. I think, and we are trying to focus on like what we call like businesses of necessity. We want to work with companies that are doing things that we believe is a necessary thing for the world. We basically need to have a working industry in certain kind of segments in order to keep up the things that is happening out in the world. So I think that is like another like prioritization from us. But yeah, it's continuing to see pushing the boundaries for how can we understand the world using smart systems.
All right. So I think it might be a final question here, just because we're running out of time. And but so where do you see the digital twin technology kind of moving in the coming years? Like it's definitely one of the use cases that are emerging and such, but how do you see it evolving over time?
I think that we will see different kind of things. I think that we see quite a lot of push from, if you take like the big companies like Meta and Metaverse, etc. I think that's one side that is that is one thing of it. Personally, I believe that people need to have real food, not avatar kind of food in a virtual world. People need to have real food. People need to have real iron ore in order to have iron or real building material to build their houses. So that is where my focus is mostly.
Right.
And I think that, but the experiences maybe that comes from those kind of things is also an interesting thing to have an eye on. But then I think that with these kind of systems also comes a big responsibility for what can you do with the system when you actually start to gather the data and start to be able to understand things.
Right.
And how can you build business models around it? Because our business model is not to sell ads or marketing as some other companies. Core business model is the data that we have is our client's data. We don't do anything with it apart from giving it back to the client. So I think that if you start to build digital twins that is interlocking into the society way more, combined with like social media, etc., it's an area, and of course AI. It's an area to both have an eye on and learn from, and have an eye on and being a little bit careful about. I think it's a lot of responsibility in those kind of questions.
All right. That is us, I think. I think we're running out of time. So I want to thank you for joining us. It's been really nice to have you here. And I'm looking forward to see what you guys are doing with digital twins and other technologies in the future. And yeah, thank you.
Thank you, Max. Nice to be here.
All right. Take care.
You too.